in the parts of the periodic table. So the first thing to point out are on the periodic table, we have the groups. These are also known as element families. So a group is also an element family. The groups or the families are the 18 vertical columns. And when we are talking about the elements in a group or in a family, we always talk about their trends top to bottom. Now, the reason that elements within the same vertical column, the same group or same family, the reason they're referred to as a family is because they have similar properties. And one of the main reasons that we will compare or say that they have similar properties is because they tend to have the same number of valence electrons, which makes them act in similar manners. The other direction on our periodic table are the periods. These can also be referred to as a series. These are the 7 horizontal rows. Now, elements within the same horizontal row, their electrons occupy the same energy levels. So electrons occupy the same number of energy levels. And because their electrons occupy the same number of energy levels, their valence electrons are in the same valence energy level. So they have the same valence energy level. So calcium is element 20. Calcium's electron configuration is 2-8-8-2. And when we take a look at this configuration, okay, the first number represents your number of electrons in energy level 1. The second number, the 8, this is your number of electrons in energy level 2. This second 8 here, this is your number of electrons in energy level 3. And this last digit, this is the number of electrons occupying energy level 4. And because 2 is the last digit in calcium's electron configuration, this is the valence information. Calcium has 2 valence electrons and they are in energy level 4. So be able to look at the configuration and figure out which energy levels are being occupied, and then which energy level is the valence shell, and how many electrons in the valence shell. So if I was to draw the dot diagram for calcium, it would get those 2 dots because there's only 2 valence electrons. Now you will also notice that I have fluorine showing up and I have francium showing up. So they kind of represent the opposites on the periodic table, okay? And so elements in groups 1 through 17, they share or transfer electrons so they can end up with a configuration like a group 18. So group 18 elements, I'm going to write a funny word above it, is they are inert, meaning they're chemically inactive. Elements in groups 1 through 17, they are definitely chemically active. They share or transfer electrons so they can look like a group 18 element. So fluorine being most to the right and francium bottom most left represents ideas of opposites on the periodic table. So fluorine here, okay, so fluorine, this is our most active nonmetal. Whereas francium, okay, it represents our most active metal, so the opposites. Now, francium is also the element that is the most metallic character. So francium is our has the most metallic character. So everything that a metal does, francium does it the most, with the greatest amount of energy doing it. Where fluorine, because it's the most active nonmetal, it is our element when it comes to whatever metals do. It has the least metallic character. So they represent the yin and the yang on the periodic table. Now, some of these groups or element families, they have names, and you need to know these. So looking at page 68. So the alkali metals, they are group 1, and it's actually lithium to francium. It does not include hydrogen, because hydrogen is not a metal. So these guys, these are our most active metals. These metals, one of the things that they're kind of famous for is that they rapidly react with water. And sometimes one of the unique things is when they react with water, you end up seeing a colorful flame on the surface of the water. These metals are also very soft. They have about the same hardness as butter, so you can actually cut these with a simple butter knife. And what makes them belong to the alkali metals is that they have one valence electron, and they tend to form a +1 cation. So they form a +1 cation. So an alkali metal, its dot diagram will look like this. Moving along the periodic table, then we come to the alkaline earth metals, a very similar name to the alkali metals. These are group 2. Now these are active metals. They're not the most active, but they are definitely active metals. They will react with water, but it's not quite as rapid. Where alkalis, their reaction is milliseconds. An alkaline earth's reaction with water, it might take a minute or so. And so they will react with water, so a little slower. They're not soft like the alkali metals. Takes a little bit more effort to cut into them or to break them apart. They belong to the same group because they have 2 valence electrons, and they tend to form a +2 cation. Move my page up here a little bit. Now we come to the transition metals. This is a large grouping, so vertical columns 3 through 11 are recognized as the transition metals. These guys are less active metals. Now, a great example of a transition metal is iron. Iron reacts with water, and when it does, it forms rust, but it doesn't happen instantaneously. It takes days, weeks, months. So they will slowly react with water. So alkali, group 1s, less than a second. Alkaline earth, a minute or 2, so it's a little bit slower. And then transitions, those that react with water, it's very slowly. So we're talking, days, weeks, years. So it takes a lot longer. They tend to have 1 to 2 valence electrons, and they form many different cations. So they form multiple cations. Transition metals, they tend to be our best conductors. And my favorite thing about these transition metals is that it is their cations that produce colorful solutions. So their cations produce your Roy G. Biv solutions. So if you buy a sports drink like Powerade or Gatorade, and you say, hey, I like the orange, I like the yellow, the blue, the green, the reason it has that Roy G. Biv color is because of the transition metal cation swimming around in the solution. Now we have these inner transition metals. They are also known as the rare earth metals. These guys are the pulled out rows at the bottom of our PT. So the pulled out rows on the bottom of our PT, of our periodic table. Many of these, when we do talk about them, many of them are radioactive. And some of them are man-made. Might be referred to as synthetic, meaning they are not in nature. So some of these inner transition metals, their existence has only been found in a nuclear reactor, not in nature. Our next to last group are the halogens, group 17. So group 17, these are our most active nonmetals. One unique thing about the halogen group, this is the only group that has all 3 phases present. So at least one element in that group is a solid, at least one is a liquid, and at least one is a gas. So it's the only group on the periodic table that has all 3 phases present. Halogens, they have 7 valence electrons, and they tend to form or favor forming the -1 anion. And halogen is a term that means salt former or maker. So its anion is the most common type of negative charge in a salt. Our last group is the group 18, the noble gases. Okay, so these guys are chemically inert. So these guys, they don't form bonds. So they don't want to be in a compound. They don't form ions. They tend not to participate in reactions. So inert or chemically inert means basically they are chemically inactive. It's not in their nature to react. And the reason is that they have a happy valence energy level. And we'll keep it simple for now, just saying that they have 8 valence electrons. And so with the noble gases, when we learn how to draw dot diagrams, they have a full dot diagram. They already have 2 electrons on each side, or a total of 8. So there are 8 valence electrons. Going back to page 67, so a couple things that I might like to write in here is the name. So group 1, this is alkali. Where group 2, it's alkaline earth. Group 3 through 11, this is my transition. And I'll probably put colorful solutions. Over to group 17, I'll write the word halogen. Group 18, I'll write noble gas. And then the little box down at the bottom, I'll write my inner transition. And I'll write myself a note. Some of them are man-made.